And talking about Mary, we have a lot of information. Mary is currently a Java developer advocate at IBM, specializing in reactive Java systems. She started working as a software engineer with C and Unix, then got into Java, open source, and web development in New Millennium. And now she's venturing into reactive, mobile, and DevOps space. In her previous incarnation, she worked for several technology product companies in the Route 128 Boston Technology Corridor, as well as San Francisco Bay Area. She now resides in the greater Chicago area, where she is right now, and is an executive board member and the director of meetings for the Chicago Java Users Group. Mary continues to be amazed by how software innovations can dramatically transform our lives. I hope she will talk about that a little bit. Despite the many challenges in an ever-evolving technical world, she gets energized by the constant change and believes that she has uncovered the pathway to stay young. That's a good thing. That's like a potion.
Yes.
She can't wait to see what the next tech wave will be like, and I hope you too in the audience. So yeah, I think we can go on by right now. Don't forget to ask questions. We will definitely have a Q&A in the end of the session. And Mary, the stage is yours.
Thank you, Agni. Thank you so much. This great introduction, a lot of energy. I am so excited to be here, to be speaking in here. But of course, what I wish would be is to be in person in Vilnius, where I came last year. It's a beautiful place. So today I will be talking about thirst-quenching streams for the reactive mind. It's essentially a talk on streams, but as they pertain to the reactive world. So I won't go into introducing myself, which Agnew already introduced me. So I'll start. Now, in order to talk about what I'm going to be talking about, I'm going to start with some basic concepts because about reactive programming, reactive systems, and reactive streams. And if you have already got information on those, you have already worked with them. So please pardon me because I'm going to be talking about some of the basic stuff first. So about reactive programming, reactive systems, reactive streams here, I also too is that I will be talking about it in the context of Java. Even though I do have to point out too is that reactive, the concepts of being very responsive, being able to recover and resilient, and very elastic, that's applied to any types of reactive framework. But primarily too, I wanted to point out is that there's also React JavaScript and then React Native. So that's more of a JavaScript framework and not the same as Java. Again, they share the same goal. You want applications to be very responsive in the reactive programming side. Now, reactive systems is a bit more like taking your systems a step beyond. It's about having your systems being, like all of the components in the systems is able to react in a very fast way. And also too, I'll be bringing up another slide that talk about the 4 tenets of a system being called reactive. And then there's also reactive streams, which is, if you're familiar with Java, then that comes out of the Java 9, the Flowable API is based on that. It's essentially reactive streams is a specification for like asynchronous processing for like non-blocking streams that will also be able to handle like backpressure. So that's what essentially it is. So let's kind of go into each piece of it. Okay. Now, when we talk about reactive programming, we are talking about event-driven type of paradigm. And for events, these are events, things that have happened that carries with it messages or data. So in order to describe them, and also too for reactive, if you're familiar with Reactive Extension, the Rx, if you work with RxJava, RxJavaScript, Rx Python, anything, a lot of language frameworks have actually adopted this Rx with them. Then we're talking about programming using streams. streams essentially carries data that's not like in a structured type of format, but rather it is more like, a stream, kind of like single, kind of, like a stream. So there are data that's associated on your streams. So to describe it, then we have the top one, streams, is like an open stream. And right now there are no events on it. And then the second one is a stream with some events. So these are marbles that represent the events with different like data, carries with it data. And then you see a perpendicular line because this stream has a definite timeline to it in which the stream will end. And it's a normal end, nothing is wrong. But on the third one, you see that there are events, then there's an X. The X signifies an error event. So you can see too in reactive programming, anything like error event, it's also like a first-class citizen. So in the past too, before Java 8, so Java 8 started having streams programming and functional style programming. Then there's the concept of these events and streams. But before that, right, we just been having, if there are errors, then we have to do try catch, and so there are exceptions that are being handled differently. But now with streams, then essentially any kind of error event is a regular first-class citizen and needs to be handled accordingly, just like any other events. And then the bottom one here is an open-ended stream. You see that there are different marbles, different events happening, but the streams keeps going even though there are events that happen. So, and let's then take a look into like some actual bit more code example and also like a diagram to describe it. This also comes from the RX Marble website, rxmarbles.com. In fact, I have it here. And if you're interested, you can look at it. And right now, I just decided to kind of show this one. It's very basic, very commonly used is a map operator. So anytime we work with a stream, that's we operate on it and operate on the data that comes with it. And so it's functional style. So in order to operate on it, it's like a function in here. So this particular function or operator is called map, and the map is essentially do a transformation. So the function itself is being specified inside in here. So you see that in this particular case, we'll be doing a multiplication of any numbers or any data that comes in we want to multiply by 10 is numeric, right, an integer. So if you take a look into the code of Rx, Reactive Extension makes use of an observable. So observable essentially operates or kind of works with a stream of data. So in this case, in terms of code, then it's observable.just, and then these are all the data, the events that carries with the data. It's kind of like input in it. Then you apply this transforming function operator called map. So the map in here immediately using a Java lambda in here, then we multiply by 10, whatever input comes in. And then immediately too, then we do a dot subscribe. So the subscribe is like my client, my consumer of the output from this operation of transformation. In this particular case, the subscribe will do also a lambda expression. It's basically using Timber. Timber just happens to be a library that I'm using, and it just prints the result back. And it's just sort of think of it like a logging thing. You log it, and it prints to whatever output you want to look at. And so now I'm seeing the output as item 10. 1 becomes 10, item 2 becomes 20, and item 3 is 30. In this case. So this is just a very basic example. There are other operators such as like filter. Filter is also quite commonly used because think of the fact that we're working with huge data sets and data coming in. What used to be before this streams style of processing, this functional style in Java, you would have to do different like if then else statement or switch and all these, and it gets quite messy. However, if you kind of do this and using a functional style of programming using reactive way RxJava, then you see that it is quite elegant. You can just apply this operator and operates on the stream. So the code-wise is being organized very nicely. So, okay, so that's a bit of a quick taste of reactive programming. And also, too, want to point out to you is that RxJS, which is Rx JavaScript, also works the same, like it has the same set of operators pretty much. So it's kind of interesting with these operators in Reactive Extension. It's kind of interoperable, interchangeable between the different libraries and language libraries too. Though not exactly, I don't believe. I haven't worked with the rest of the language implementation, but pretty much a core set of operators they share among different language frameworks. So I like to kind of point that out. Yeah, Reactive Streams essentially is also for other languages too. Okay, so here, then let's take a look then into the next discussion is about reactive systems. So every time when we bring up in the Java world, we talk about reactive systems, we cannot move away from this diagram of essentially 4 tenets that define what a reactive system should be. So these are characteristics. They must meet them in order to be qualified as a reactive systems. Now, as such, in reactive systems, as I mentioned earlier, is a step above just the reactive programming. When we do reactive programming, we are doing all of the programming on a particular maybe microservice or a component or a method or a routine, a small class. But for reactive systems, we are really working with the system as a whole. So think of kind of more abstract, you bring one level up. Then there could be many microservice components in a system, and they all are not tightly coupled. They're loosely coupled, but there would be way to make sure that they all function in a very coherent fashion. And so essentially, too, when you think of it, reactive systems is not just dealing with the the programming part, but it's really dealing with the events that are happening. We want to also coordinate all of the components to work together, so to speak, like peacefully, kind of like that. So these are the 4 tenets that a reactive system must meet. And also, too, this reactive manifesto is led by Lightbend, the company that's invented Scala. And also then they have this product called Akka, which is the reactive library. So they are the ones that have been leading this reactive manifesto. Essentially, it's a guideline. So first of all, responsive. By responsive, it means that system needs, all of the requests comes in, it needs to be able to respond to requests in a very timely fashion. There shouldn't be any performance degradation. And then if you look into the right side, then resilient. By resilient, it means that any kind of components, if there are error, then it needs to be able to immediately be taken care of. It's like responsiveness. You need to respond. The system needs to have a mechanism to respond to any kind of error condition, fix it, and be able to get the system up, be able to make it like recover as soon as possible. And also to overall, your responsiveness, your performance of the system should not degrade. And then if you look over to this side is the elastic property. Elastic, it means that system needs to be able to become very flexible in times of load. So if they're like, for example, an e-commerce system during Valentine's Day. So right before that, there are tons of orders, from especially the gentlemen want to order flowers for the ladies. Then you see a spike, in all your orders, order entry and order processing. So the system then should, being very responsive and reactive, then the system needs to be able to handle this load that comes in. It's either you increase the number of processes to process these extra requests that comes in, or you have to do some sort of backpressure control. So then you kind of stop the request from coming in too fast, and you have to kind of control it, like kind of control some sort of throttle, for example. Or you can just basically kind of drop some of these requests too. I mean, that's an extreme case. But anyway, the idea is that your system needs to be very elastic, being able to be very fluid, it's very scalable. And then during time of when it's quiet now, there's not as much order. And so in that case, then your system needs to be able to kind of shrink back and not be running so many processes. Maybe just leave 1 or 2 waiting for orders. So that would be like an example of like being elastic. And in the modern computing infrastructure, now we have like the cloud, containers, and cluster. And in fact, the elasticity can also be handled by the cloud, cloud native type of reactive microservices. That would be kind of handled by the cluster too. And okay, so now all of these, all three, I'd say they are kind of essential kind of characteristics. Then the next thing, the message-driven too, is a bit more describe, what the system, how it should be, done in order to support all of these other properties. Is basically is the very message-driven nature of your system. So by message driven, it means that you are all the components are not linked together, so they are kind of all loosely coupled. So in order to communicate between themselves or between like any component with some outside components, is all done by messaging. So that's kind of message driven. And also a note too about message driven and event driven, it's kind of not exactly the same. Message driven is that you have messages that are known between the address, between the sender and the receiver are known. So if I'm a sender, I know that my message will go to, from A, I'm going to send to B, and I have the address of B, or in some ways have some references that I'm telling the message to go to B. But for event driven, it's essentially, it's not known. And very often too, in a system that's called publish subscribe, like pub subsystem, then it would be messages that comes out on a stream, producing, whoever produced the message, we usually call it producer or publisher. You publish those messages. It doesn't know where exactly it's going to. It's more like, okay, I'm publishing something, and it's up to those who are interested in the messages. They need to subscribe to it. So in reactive extension type of operator, when you see that, is that I have to do a subscription. I have to subscribe to it if I need to consume these messages. So they are producer, consumer, or publisher, subscriber kind of relationship. So events would be more like, if I'm interested in it, I subscribe to it. Kind of. So those are kind of the differences. So, all right. So let's then take a look. So what exactly then reactive systems are trying to solve? Ultimately too, is really what we're dealing with is a world of concurrency. We kind of all live in a world that's not just if we're going to to do something, we won't just wait. I often like to use this example of us going to shop to do shopping. And in order to, let's say we go shopping and we're hungry, then we go and order some food. And say the food's got a long line, so you order your food rather than waiting. I mean, you can wait too, but the idea is that, and it's similar to what we try to achieve in computing, especially in the kind of reactive world, is that we want to be able to allow you to have more time to do other things that are useful. You don't just sit there and wait. So the point is that you order food, then you get a ticket, and you take the ticket with you, or maybe take a beeper or some form of notification. You go off and do your thing, and then when your food is ready, you get notified. Then you go pick up your food. So in a computing sense, that's what we're trying to achieve too. Is that we have processes that happens, and we do want to do things asynchronously. So then we have some requests that kind of get sent to the processing side. In the meantime, the requester will just go off and do something else. We don't want to just, be blocked and wait for it. So that's the idea. So, okay, so then comes back to here about concurrency. So concurrent, let's take a look, which is essentially dealing with multiple tasks all at once is concurrency. And then there's also slightly different, not exactly the same as like parallel. So okay, so before all of these current kind of cloud infrastructure that we are having, the clustering, and multi CPU machines, multi-core machines, basically, yeah, machines were simpler. They may have just one CPU, and then essentially too, in order to achieve like parallel processing, then we have to be employing like threading techniques, especially say in Java. If you do Java, you're familiar perhaps with threading. And we can understand too is actually, if you do threading, it's powerful, but also not very easy to do. It sounds simple. Maybe you have like your runnable class, and then you have a run method. But the thing is, it really can kind of get you into like a big, maze, because anytime when we deal with programming that have data that deals with asynchronous in nature, and the timing of when the data or events will happen, that's not very easy, as we know. So okay, so that's that. And also one thing to point out is that with parallel computing is that it can happen in back when we actually have single CPU, single core machines, because parallelism will require a system to be able to handle processing. And then if we have multi-CPU machines, then that's when parallelism can be achieved. But in today's world, as such, we have multi-core machines now that actually concurrency can be achieved like through software. So, all right, so let me kind of go a bit more into the next slide more about reactive systems. So when it comes to reactive systems, there are certain patterns that actually the Lightbend folks have also published a book about, and I have the resource towards the end of this slide. It's basically, in order to do, as we know, if we're dealing with systems that are, made up of so many different components, we need to be able to make them all work together in a very coherent fashion. They're not clashing and all that, even though they don't have direct contact with one another. So some of these are like patterns that are like commonly that we have to work with for reactive systems. First and foremost is the backpressure. I mentioned about it earlier too. So backpressure is if you're not familiar with it, is that usually in the asynchronous style of processing, that's a common issue that we have to deal with, because you can have many requests coming in. And the thing is too, is that if it's not handled properly, then the pressure builds up. That means your request coming in, and then the one that's processing cannot handle all of the requests that are coming in. So that's kind of like backpressure. So you can have the requests coming in, and basically the pressure kind of turn around. So you kind of have all these pressure pressing on your processing part. It doesn't work, then basically it will kind of like turn itself back. And I have the next slide to describe it too. And so like in reactive systems, is that reactive streams is essentially a specification that kind of indicate that backpressure needs to be handled accordingly. And then another kind of common scenario for design patterns would be circuit breaking. So circuit breaking, if you're familiar too with electronics, then it's same kind of concepts, is in which if there are errors that are in your system, then it needs to be stopped essentially and be handled accordingly, whatever components is causing trouble. So you break that and let it be heal itself or some kind of healing before you actually bring it back into your whole circuit again. So that's circuit breaking. Now, kind of go back to a bit more like a newer type of concepts and which kind of turn into a design patterns would be event sourcing and also CQRS. So event sourcing, I won't go into all the details, but like in a minute to talk about it, is essentially we want to be able to capture the change of state in the data like over time. So instead of like storing all of these states directly into your database, what we will be saving is basically capturing the events of this data in different, its state in different space and time. So what will happen is that in the future, we want to be able to go back to figuring out what the state of this data is in at a certain time. Then you can essentially do a replay. You take the records of all of your events and do a replay. Then you can essentially kind of figure out, what states it was going through for this data. So yeah, so that's essentially that's what event sourcing is. And if you're familiar with it, I'm sure you understand like this part. But okay, so now then let me turn into the next thing, which is CQRS is command query responsibility segregation. The idea is that we want to separate out the write API with the read API. So then in any type, in the systems itself, this will become a bit more efficient if in that sense, because then you're separating all of the write in the same process to do write, and the other is only handling read. And it makes sense. Although the thing is too, is that it does kind of get into some kind of difficulty too. As you can see too, you kind of separate out, yes, each of them is efficient, but it also kind of have a bit of coordination you need to be doing too, if you need to be doing, let's say, replaying your events and things like that too. So, okay, so that's that. So these are like commonly used reactive systems design patterns. So let me then move to like streams processing now. So in any type of streams kind of processing, there are essentially two models. One is the push model and the other is pull. So for push, it essentially means that upstream data will pushes the data to downstream, and that's also what we call as hot observable in the Rx reactive extension RxJava, or Rx, just simply Rx. It can be RxJS or Rx Python or anything. So that's also being called like hot observable. Hot is because it's essentially the data that's from the publishing side. It's hot. It doesn't need to be told to do it. It's a bit more proactive, kind of in that sense. So the upstream will push the data to downstream. Now for pull, then it will be for the downstream, like the consumer side. I need some data, and in a observable kind of a paradigm, then we'll be calling it the downstream will subscribe to the data from the upstream. Then so for that we'll call a cold observable, because in the upside, in the top side too, it's kind of cold, you know. So I won't do anything. It's kind of lazy until somebody subscribe to me. Then I'm gonna go to start doing something. So and let me kind of show this in a diagram. It's like for push, like in a if we look at event-driven kind of push streams, this kind of model, the producer is trying to emits data, and it admits, and how does it know to go down to the consumer? To push it to downstream is it will just send, you know, the push will be like I send the data to the consumer without being asked explicitly. That's more like the push model. And okay, so now, and then then there's the other model is the pull. So the consumer will need the data. So I do a dot subscribe. Now, interestingly, if we look at it, reactive programming is that it's different than traditional way of programming. When we do a dot subscribe on any kind of stream, the data is actually not there yet. And you know, bear in mind, we're dealing with asynchronous, dealing with data that can be happening in the future, something that will happen in the future. But the one who's subscribing to it won't wait for it. But I'm signaling that I want to subscribe to it. So it needs data. So the time comes when the producer has produced the data comes in, then it will then sends it over to whoever has subscribed to it. So that's pull. So interestingly, like for reactive streams too, the way the model is more like a pull than push. It's more like the consumer side needs the data, so it kind of holds on to a future object. So when the data is ready, then basically the future object is like promise. I think also in JavaScript too, a promise then is like a promise, right? Then things happen, then I promise that the data will be there in the future, kind of like that. So, all right, so let me then go to the next one. Okay, Backpressure. Maybe I should have moved this slide up when I was talking about those patterns. So it's just talking about, you know, Backpressure is if you get too many requests coming in and I'm trying to run towards it, like then the pressure will kind of turn around in here. So it kind of like push it back to the front. So another diagram to describe it, it will be like a shower head. You know, you shower head of publisher admitting all of these events and, you know, all these requests, then the subscriber, I'm here. I can't, you know, kind of deal with, you know, this pressure. So publisher basically generates more data than the subscriber want. So, all right, so let's kind of get a bit closer to the coding level for reactive streams. There are actually 4 interfaces, and these are the ones that I described. It sounds simple, but it can get into quite difficult. As such, we're talking about dealing with asynchronous style of processing, and it sounds simple, but when it gets to doing, because of, again, we're dealing with data that can happen in the future, we're dealing with time-sensitive kind of processing, or actually time-sensitive, but also to asynchronous style of programming. We're dealing with what used to be us handling as threads. They are just not as easy to do. So therefore, a bit more closer to presented into code this way is there's publisher, subscriber, and the subscription. So subscription is where the backpressure support will happen in here. And there's also the processor. Subscription is interesting, is essentially it's a more abstract way of describing a subscriber and publisher relationship. So basically, subscriber will subscribe to the publisher, whatever is, you know, signaling I need to, you know, subscribe to it. So once you have this subscriber-publisher relationship established, then there's a subscription there. So that's where backpressure support will happen there. And then there's also then the processor part that essentially, you know, you implement what needs to be done to process it, this particular subscription. So. Okay, so let me then, okay, so here too, let me, kind of list out a few more popular Java libraries that have support for the reactive streams. And again, reactive streams, this is the API, org.reactive streams. And it is only a specification. It's going to list out all the specifications, and there are no implementations because it's up to the libraries that implement them. And there's also a TCK, which is the testing compatibility kit that will qualify. Essentially, if I want to develop a library that supports it, I have to pass this TCK test first. And the idea is that it's promoting interoperability among them. So you can imagine that you're trying to build a pipeline of processing some data that happens, through time, through different events. You can essentially implement one part of it using like Spring Reactor and Reactive Extension. And by the way, I grouped these together because the RxJava 2 and also Spring Reactor, the project reactor from VMware, or what used to be Pivotal, they are the same group of engineers that work on both. So their operators kind of are very similar to each other. So I grouped them together. And then there's also Vert.x, which is from the Eclipse Foundation. Vert.x is a reactive, very lightweight library. Then Akka streams from Lightbend, and from this, essentially it's built on top of Akka, and then from Lightbend. And then there's also MicroProfile. I'd like to point out is an Eclipse Foundation project. That's essentially targeting for more enterprise application type of usage. Also focus more on like microservices implementation too. It has support for reactive messaging as well. And then there's also a newer library called Reactive Socket, called RSocket in here too. But yeah, so the idea I was going to say is that you can actually be developing a portion of your pipeline, right? You want to build your data flow through a big pipeline, different stages of processing, and I can have one doing it in RxJava, and then the input and output. The output could then be connected to a Vert.x implementation, and then later the data too, after processing it, goes into another pipeline that's maybe Akka streams, and then you kind of link them up together. So you can kind of be quite creative of using this too. However, one note I like to point out is that now Reactive Streams has all the interfaces. You do not want to use these interfaces directly, and you would rather choose to use these libraries because, again, of the complexity of if you have to deal with kind of asynchronous style of processing these streams together, even though 4 interfaces, but they do get quite kind of difficult to do it. So, okay, so quick thing is that, let me step through quickly. So Spring Reactor, it makes use of the reactor core. It has concepts of a flux and a mono. Is either flux is WebFlux, as you've heard of. WebFlux is the web framework from Pivotal that handles like reactive streams. You can handle fluxes 0 to n items or streams in your event there. And then there's also mono, which is 0 to 1 item. And okay, let's see. Oh, don't time. Okay, thank you. Okay, and okay, so then there's also RxJava, which I already talked about, but I want to point out is that Observables and Flowables. So Flowables are the version 2, which with Backpressure support, but we often see is Observables, which is RxJava 1. And then there's Vert.x, and let me kind of quickly go into some code example to show you too. So Akka streams comes from Lightbend, and but without going into all of the details because it does kind of get complex. But I can talk more too maybe at the Q&A session if you want. And then there's MicroProfile. The focus is on microservices, and it integrates very well with OpenLiberty, which is an open source version of WebSphere too. And quickly to kind of point out to MicroProfile reactive messaging, how it's being done is basically through the naming in how you annotate your method. So if you annotate it, and then basically then if you have method 1 outgoing, specifying it outgoing through the order channel, then it's kind of connecting with another method that actually has an incoming label of using the order in this case, so on and so forth. And now RSocket, quickly to say it's a binary protocol for use on byte stream transports, highly efficient. The version 1 came out, I think was early in July or something, so quite new. And if you're interested too, you can check into that. There are essentially 4 models, 1-to-1, request response, or 1-to-0, fire and forget. Then there's also requests to multiple stream, like one-to-many, or like a channel too. It has bidirectional channel, so you keep the connection kind of open too in that case. And quick thing is that RSocket, this is a diagram I borrowed from the Spring One platform. They let me use it, and you can see it's still using Pivotal back then, but now it's VMware. So, so these are the companies that formed this consortium sort of together in the under the Reactive Foundation. So RSocket is open source layer 5 and 6 communication protocol based on Reactive Streams, and it's very efficient. And as you can see, it handles like backpressure because of its support for the Reactive Streams too. And it's very flexible, and it's for every language, not just for Java. It also has it in Python and JavaScript and others too. So it can be used for mobile, edge, and IoT, so highly efficient. In fact, if you're doing AI, doing machine learning, all the big data processing, you can also consider using RSocket to process, especially doing like real-time processing. Imagine you're training a bot. I also actually did a talk with a speaker from the Reactive Foundation, Oleg Dohuha, and we did it in training a machine learning bot to play like multiplayer Pac-Man too. So if you're interested, let's talk about it in the session after. And quick information to their streams. There's also this OSGI from this organization. Actually, OSGI will be incorporated in with the underneath the Eclipse Foundation. So they actually implement a true push stream kind of implementation. And there's no dependency that it requires. It implements its own API as well. And currently at release 7, and it will rely on the OSGI promise. They work hand in hand, but otherwise too, there's no need for you to use other OSGI framework. And one note to point out is that OSGI is the framework that's being used by the Eclipse editor too. If you're using editor, the free Eclipse IDE, so that's OSGI underneath the hood. It's very modular library. So, okay, quick thing, the reactive primitives too. If you compare, this, like I said, the Reactive Streams got the publisher, then that's how we map it. And one thing to note is that for Reactive Streams, it's subscription, and basically push streams will have an auto-closable. But that's the difference too with the push streams. It actually allows you to close your stream directly, whereas the Reactive Streams doesn't allow you to kind of have that close of a control over a stream. So. All right, so I think I probably have a little bit of time, but let me quickly then go into showing this some code quickly. And okay, so just to very quickly show you, it's this implementation too using Vert.x. So in Vert.x too, there's also, well, actually, I wanted to point out tomorrow I'll be doing a workshop with my colleague Grace. So that I will go into a bit more into this if you are interested too, and giving you some hands-on experience and also how you can deploy this to a Kubernetes, OpenShift Kubernetes cluster. You'll get hands-on to play around with the Kubernetes cluster. So please watch for my workshop tomorrow. So, and this is just an example of Vert.x. All I need to do is hello world. I need to extend the abstract vertical. And then I basically then override the start method. And over here too, you can see that what I'm trying to do is that I'm using a flowable to handle my streams. So over here is the server. In here, I create Vert.x. I create an HTTP server. I basically do a .request stream. I kind of convert it to a flowable stream in that case. So in this flowable, I immediately then do a subscribe. I'm not doing any other thing other than just doing straightly a subscribe. I can, right? For example, earlier I talked about you can do a .map. So you transform the data that comes in or filter something. You can do that too. But in this particular case, I do a .subscribe. So my subscribe immediately, what it does is using a Java Lambda, I basically have a handler in here that handles the request. And first I get the target, some environment variable, I take it, and essentially then I build out my response. So in my .response, I also set up my header and status code, and doing a .end is hello world. So what you will see in here will be, if you run this, then it will just say hello world, whatever is being set here. If I want to set my environment variable to, let's say, target equals over here, say build stuff, then what will print out is hello world build stuff. And over here too, and that's the difference too about doing reactive programming, because like functional style over here, my server is also, I wanted to have it listen on port 8080. Now, in order to start the Vert.x runtime, all you need to do is Vert.x.Vert.x. That's the control center. And then you do a deploy vertical on this hello world, and that's how you do it. So okay, so that's a very simple example of showing you quickly. I know this is a lot of information, but join me at the Q&A. We'll talk more about it. In the meantime, let me go back to this because I believe I only have 2-3 minutes. So, okay. So tomorrow, please join me about the Vert.x workshop. I will kind of show a bit more about this particular polyglot use case of Vert.x too. But in the meantime, I think I have 3 minutes. I do want to thank you all for coming to my talk, and I wanted to let me see. Let me kind of run it. Play. Oh, sorry. Actually, I got it wrong. Let me do that. Sorry. Okay. Here. Okay, so just leave 2 minutes. So I'll just give you some information about myself. If you want to continue our conversation, I really welcome you to do that. I have actually a Discord server too, that if you want to have more chat, please join me. And this is the QR code for if you're right now in front with your cell phone, you can just scan it and join me on Discord. Then this is my Twitter handle and my GitHub and my dev.to. I also will be starting a blog in there. Then my profile on IBM as an advocate profile. And then these are like information on some more reactive systems resources on the IBM website. And the rest here too are the different reactive information that I talked about. So Reactive Manifesto, the reactivestreams.org Reactive Foundation, and the design patterns, if you're interested in that, is here. And then OSGI too, this is about their push stream. And then IBM too, we also have a Java newsletter, as well as other newsletter like AI, IoT and Watson and all these things too. So if you're interested in that, I kind of invite you to also sign up for those newsletter. You can always unsubscribe too if you want. So. And here too, I wanted to point out there's also an IBM Cloud that you can sign up for. The reason I bring this up is that if you'd like to join my workshop, then we will be using an the IBM Cloud account to do that and using OpenShift tomorrow. But if you come tomorrow too, you can sign up there as well. And otherwise too, in the meantime, if you want to just get a free account, you do not need your credit card. So that's a nice thing. There's some free tier usage. There's also very simple Kubernetes cluster if you want to give that a try. So we invite you to sign up for that. And then these are the different reactive streams resources. Again, I will make the slide available to you so you can look at them offline. And also one more thing is about my Twitch stream. I have a live coding stream on Twitch every Wednesday. And this is actually, I should say GMT -6 now. We're back to winter time. So it's Wednesday around, I think it will be like around 8 o'clock your time. Then that's when I have the stream. So I invite you to join us. It's on Twitch. It's IBM Developer. So I'll be there. And with that, I think I should be on time. Yeah, and wanting to thank you, all of you, for being so patient in here. I invite you to ask more questions if you're curious about Reactive or if you want to know more, please connect. And thank you very much again for attending my talk. And
thank you, Mary, very much. That was extremely high energy for, I know you're early, it's early in your side of the world, so it was extremely energetic. And yes, I too want to invite the audience to visit the chat with the speaker room that you can find in the Pine Tools virtual rooms just under the Queen stage here, where we are right now. And there's the banner saying chat with the speaker right now. So all the questions will be answered there, and I'll meet you on the other session. Mary, thank you very much. That was awesome.
Thank you for your help in the back room too. Thank you. So okay, great. See you.
Bye bye.
Bye.